Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to show you some shims that we're making for a client out of acrylic, 5,000 total shims, 1/8 inch, black, and plastic, and 2 different shapes. So that's what this is going to be about. Okay, so I just went through an air cut on this, and everything looks like it's just fine. So let's just move to cutting this. Okay, so the prototypes look good, nothing unusual. Just put the letter on there just for the sake of doing it. I don't know if we'll want to do that moving forward permanently. I'll just ask the client. It might make it nice to know what was put there. And I'll probably do something else as well. Client doesn't care if they're matte or gloss. I like gloss because it looks a little fancier when the paper comes off, I should say, but I will look at the material cost. This is going to meet the requirements. I bet what they would love is that it didn't have the paper on it. They want 3,000 of the C's, 200 of the D's, 200 of the E's. And boy, that's a lot of items to pull paper off of. I don't know that the plexi I'm going to order is going to have paper on it. It won't matter. And in fact, I would want it without paper, but that'll just be life in the big city. Let's switch to the screen view, and I'm going to prototype. I'm going to take the vector and array copy toolpath and figure out how many sheets of 4x8 we're going to need to run all of these parts. Yeah, it should be no big deal. I'll probably take the C shim and toss it onto a C layer, D layer, E layer, and just be able to look at that in the same VCarve file. So let's figure out how many sheets we're going to need. Okay, so the website I had mentioned is eplastics.com. I was initially looking for the 1/2 inch polycarbonate. These folks I eventually found, and their website is very usable. It has a lot of technical information, and I'll tell you this. I've called them 3 or 4 times, and every single time I've called them, I have gotten a professional expert answer right away. So I'm looking at plexiglass. Black and white plexiglass sheets. I'm going with 1/8 inch. I'm going to go with 48 because I can't fit anything bigger. Got to go with 8 foot because they don't have 10 foot in black. Now, I think P95, that might be one side gloss, one side. Yeah, it's very, very slightly more expensive. Paper masked black plexiglass acrylic sheet. I don't know what this 2025 is, if it's matte or gloss. The conversation with the client was the application does not matter. You never see this. And the client said, whatever is less expensive. And I said, well, rather than less expensive, we're going to go with lead time being the most important thing because they've come back and said they want to see this in 4 weeks. Well, today is December 22nd. The rest of the month is basically shot. And I'll be taking a trip to Europe for a week, the 3rd week of January. So the idea is that we get an order the 1st week of January. I order this material and it arrives before I leave to go to Europe. And when I return from Europe, it's straight to production. That's at least the concept of what we're doing here. So we'll leave these tabs up. And let's pull up the V-carve and see what we can do here. So what I'm going to do now is I'm going to calculate a total for this client and I'm going to send them a quote and we're going to see what they say. I will certainly divulge the number that I come up with. We'll leave that for a little bit of suspense. We'll see if that's not a digestible number. The issue is you've got a lot of machine time. Now, if it's going to be a kick down, drag out in terms of price, which it may be, I'm definitely going to do some optimization on a single pass, which realistically is what I should be doing. And I'm going to be able to reduce that machine time down substantially, obviously. Getting rid of the letters that are on there, that's just bragging, I suppose. But reducing the machine time is the bottom line. So we'll look into all of that and I'm going to come up with a price. So when we pick this up, we should hopefully have a very interesting development. Great. It's December 21st, 2024. We'll pick it up.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, so I had the weekend to calculate the price. Well, that took 2 minutes, really. And these are really, really expensive things. And the primary cost, naturally, is the machine time. The cost for 3,400 shims is $58,000 to the client, with tax landed to the job site. And it's very possible that whether it be $58,000, and if you divide that by 3,400, it's $15.80 per piece. If you consider $15.80 and you say, well, I will be able to optimize the toolpath to reduce the machine running time down, which is basically 250 hours. If I get it down by 25% and they become $13 each, it may not really matter because they're not going to be $3 each or 89 cents each. That's the bottom line. You've got several thousands of dollars of material cost alone. You've got material cost, which is the second most expensive thing. But then you do have programming time and you do have tooling. How much of that tooling is going to get used up and thrown away? But it's really how long the machine's going to run. And then it dawned on me over the weekend that what I would do is simply run an entire sheet so that I can time it. I can actually time it and compare it to what VCarb says in terms of a time, because the price that I want to give the client simply needs to be accurate. Plus, once I have that sheet, I can get a better idea how long it will take to post-process, cut them out of the sheet, this and that, make them appropriate. And what I'm going to do is use just a piece of 1/8" tempered hardboard. I've got some tempered hardboard here. They're all going to literally hit the trash when I'm done, but that's okay. It's a sheet of tempered hardboard, 1/8". So I'll make some adjustments for that in terms of material thickness and feeds and speeds. No, I'm not going to. I'm just going to cut tempered hardboard with the feeds and speeds that I have right now because those feeds and speeds are actually close to where I think they're going to need to be. So I'm not going to tweak that at all. Then obviously what I would do if I were to get the job. So let me back up. Confirming the machine runtime. That's what we're going to do next. If I'm able to tweak it after I get the job, if I get the job, then that's good for me. That's just going to work. I guess what I'll do is I will get a sheet of 1/8" tempered hardboard loaded up onto the tool, and I'll get the machine up and running and turned on spindle warm up, C5, 1/8" tempered hardboard on there. Before we do all of that, let's look at the screen view for the visualization of what I'm going to cut, and we'll see the time. Then the next video is probably just simply going to be a time lapse of me loading the tool and setting it all up. Then it'll be an overhead cutting everything. All right, let's get to work. Let's do it. I want to give them a number. Today is December 23rd. I told them they'd have a number before the holiday, which would certainly be tomorrow. And let's get cracking on it. So let's do it. Okay, let's take a look at what we have running here. The cost to the client is material cost, which is the 1/8" plexi, plus the tooling, plus the programming time. The prior work to date, I do want to build in what I've done to date. I want to be remunerated for, so far, the 3 rounds of prototyping that I've sent them. I've bought material, I have paid for shipping, my time is not free, then plus machine time.
plus the freight to the client, and we're going to need to calculate a weight on these. I actually have a shim here that I'm going to put on my fancy scale, but freight to the client. This is all thought of as my cost. We have to have our markup. We have to charge sales tax, and that will be the sell price. We do have 250 hours so far of calculated runtime. We have 42 sheets of plexiglass, and I'm going to run one sheet of the C shim, and VCarve is telling me 5 hours and 2 minutes, 22 seconds. So that's what we're going to be testing here. Let's do that visualization. Those are our C pieces. How many are we going to get out of this sheet? 89. Yep. Okay, so we're going to preview these. Let's get this party started. All right, so that's the visualization of what we're going to do. Double clicking on those gets rid of them. Awesome. I'm going to set the tool up. Let's get this party started. Let's array toolpath C and the second C. I should rename that to C2. And let's close. Before I do any of that, what I need to do is check my job dimensions. I'm going to pause this as I measure the piece of 1/8 inch tempered hardboard because we've got 0.113. I don't know if that's accurate. Okay, this material is actually 0.124, so we're going to recalculate. And I'm going through to 0.143. I bet we're okay. The only difference here is that my tabs ought to get thicker, and I'm okay with that. So let's just change the material thickness, and let's leave that be. I think I was going through just a little thick anyway on these parts. So now everything's recalculated. Let's save the toolpath. C sheet array, 89 pieces, 1/8 temp cardboard. Hope that file name's not too long. We've saved the toolpath. Okay, let's set the machine up and let's start cutting. Here we are setting up the tool. Our piece of 1/8 inch tempered hardboard. So what I'm doing, here's what's happening. I picked up tool 2, I zeroed it to the ATC. I'm gonna run a C5 now, which is spindle warm up. Next, I'm gonna load the hardboard. Once the C5 is done, I will turn the pumps on. I'll zero to the material surface, and we'll start cutting. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, let's run the tail of the tape. First thing I'm going to do is turn off all the equipment because it's making an awful racket. So stand by. Okay, so let's take a look. I do have definitely some observations. The tool ran perfectly fine, no trouble at all. Let's take a look at the bit. I'm not going to be able to get the dust free off. It's perfectly cool, perfectly room temperature. No trouble at all with the bit. I know it's dark under here, but we're still using that down spiral, and I'll tell you this, it certainly feels very sharp. I wouldn't say that it is as sharp as a new tool, but it certainly still feels quite sharp. So my first observation was quite some time ago is I had wondered aloud if the array copy toolpath accounted for the margin and whether or not this ½ inch accounted for the curve. And it does. So the bottom line is I'm going to squeeze that down to ¼ inch. There's 19 of these areas. This is 4-inch wide, so I'm going to need 4 times 4 is 16. I'll be able to get an entire 4 more out of each sheet, so that's 93 pieces out of a sheet. And that's going to save me an entire sheet. I'm going to be able to get another 4 out of each sheet. So for every 20 sheets I run, I pick up 4. And I'm going to save 1 sheet, is the bottom line. I'll save 1 sheet. So we'll reduce that down a little bit. No sense in reducing this down a little bit because it's not going to save us any room, or meaning we're not going to be able to pick up any additional area. Everything here looks like it's really good. I mean, these pieces come out. I mean, that popped right out. Even with the marginally thicker material, our tab, even an MDF, is really tiny, but really in position. No problem at all. What we were doing was running it for time. So I started at 12:47 p.m. and it ended at 3:43 p.m. So 2 hours, 57 minutes. So 3 hours a sheet, and I was calculating basically 5 hours a sheet. So 42 times 2 is 84 hours. 250 minus 84 is what, 168 hours? So that's a huge drop in the cost of this job. Now, also what I'm going to end up doing is, I've realized, as this is all cutting, I'll have 3 hours before I can pull the sheet off, and then literally just start liberating the shims off of here. So I'm really never going to be spending double time, because when I'm not popping the shims off of the scaffolding, so to speak, I'll just be working doing other things. So I'm feeling really good about having just substantially reduced the cost of this job down big time. So I'm going to look at the formula again to make sure that we're good, and then tomorrow I will quote the client because it is very close to quitting time, and I will let you know how I got 58,000 or what I got 58,300 down to. I'll make some notes for myself and we'll move on. But I'm really happy with how this all looks. Okay. Time to turn the tool off, and it's a day before Christmas Eve, so there'll be a little bit of merrymaking coming my way in the next couple hours. Thanks. We'll talk to you tomorrow. Hey, B Supply, this is Richard.
Hi, Richard. It's Shims out at Turner Construction.
Hi.
Hey, how are you doing?
Oh, fine. Yourself?
I'm all right. I replied to your email this morning. My question, I guess my scope is, it's kind of pertaining to fluid. It's a little more fluid than maybe I'd like, but we may actually need more than the 3,000 shims. But pricing-wise, I was expecting for it to be a little lower. What are your thoughts?
Sure. Yeah, me too. Yeah, I mean, what is immutable is the time that it takes to produce those. And whether it be 3,400 or it be 10,400, time is still time. And other than looking into optimizing my tool paths and sacrificing in other areas like edge quality and wear and tear and tool life, I'm not seeing, you know, and quite frankly, the first number I came up with was $58,000. And what I then did was, because the scale factor in the CAD/CAM software was telling me X hours per sheet. So I ran a full-size sheet out of 1/8-inch tempered hardboard and realized that the scale factor was substantially incorrect. So I was able to optimize the amount of time. So I know how long it takes to the minute to produce that sheet. And as a result of that, when I saw the number, I'm thinking, well, it is what it is in the sense that machine time is machine time, but these are never going to be $2 or 50-cent injection molded pieces. These are always going to cost money because of the amount of hours. I don't recall how many hours, but 150 hours. That's just machine time. That doesn't include all the post-processing that has to happen, which isn't a lot, but when it comes off the sheet, it's a skeleton, it's a scaffold, and all of that has to be handled. And while the machine is cutting and one person is liberating, you know, that's not 1 + 1 = 2. It's just still 1 plus 0.01. You know what I mean? We don't stop the machine to liberate pieces, but that number is to the minute.
Sure. And so C, D, and E are 50% more expensive than C. The reason for that is the same, just time. They're bigger pieces.
The answer is no, except that the answer is kind of yes, because when the machinery is moving in a Z approach from XY1 to XY2, there is lost efficiency there because it's relocating, but it's primarily because the yield per sheet is substantially less. So we require more sheets to produce 100 of D than it does of C. And that's the software basically telling you, here's how you nest these parts. So as I look at it and say, where can I cheat this? And I've already gone and optimized slightly, but I'm literally looking for 1/8 of an inch. And I don't have enough eighths to get 4 more out of a sheet. So and then when the piece comes off, I got these tiny little margins that it's way too frail. It'll fall apart as we're taking it off the tool. So there has to be enough scaffolding to keep everything together while it comes off.
Okay. So just to get some more clarification, quantity is not really affecting your price per unit. It doesn't really make all that much of a difference.
Not really, because I'm already setting up to do 150 hours of machine time. Could we realize some additional efficiency by making it 7,000 sheets? You know, not really. I mean, it would only be a matter of reducing margin to say, oh, well, if you want to go to 10,000, here's a different price. But it's only reducing my individual margin, and it wouldn't be a lot. It would be beneficial if you knew absolutely you needed whatever X thousand. Then sure, I can go back in and find the quarters between the seat cushions, but that's all I'm looking for at this point.
Yeah. Okay. All right. Well, if anything else comes to mind, shoot me an email. I'm kind of trying to figure out the logistics of how soon we would need what quantities, and the pieces themselves, the shims themselves, look great. I haven't measured them out. I don't have the columns themselves, so I can't reference them against their base plates. I'd like to do that, but let me do some digging. If something comes to mind, shoot me an email. Otherwise, I will reach back out probably before the end of the week.
Yeah, the only thing that I know is going to come to mind is my unavailability between the 20th of January and the 1st of February because I'll be overseas training employees. So the only thing that would be of benefit is that I got the plastic on order and that it was here when I returned. So that come February 1, when I'm back here, it's just fire it up and cut.
Okay.
When I spoke to the plastics people, they had 100 sheets in stock, whatever it was, last week. And if that number doesn't change between now, it's just I've got that blackout. So unless I had an order today and I had sheets in 2 weeks, there would be nothing occurring until I got back from Europe.
Gotcha.
So there you go.
Okay, I'll keep that in mind, and I will figure out sort of logistics, and I will get back with you.
All right, sir. Thank you very much.
All right. Thanks, Richard. Bye.
Bye-bye. Hi, it's Rich, Architectural Builders. Is this Sim?
Yes.
Just wanted to find out from you what happened on the custom shims. How did that? What?
The Shims is this is Richard.
Yeah, Rich. Yeah, Richard.
Hey, Richard. So what it is we couldn't get the engineer to sign off on plastic. They want steel, which has been a real pain in our. It's a real thorn in our sides, but they want steel.
Huh. Well, you need somebody with a laser. I mean, I've never tried to cut ferrous on the machine. You need somebody with a laser cutter, but at that point, it should be easy peasy.
Yeah. So we may not actually even. We're still trying to figure out. We went through a lot of hoops, talked to a lot of different departments of engineering to try to figure out if somebody would give the plastic shims a pass, but nobody wants to be responsible for plastic shims under steel server racks. So we're still kind of figuring it out.
Yeah, I can mill aluminum, but if they thought plastic was costly.
Yeah. I'll keep you updated, man.
When I do a right now we've got if I do a pass on aluminum, I'm not doing more than 10,000ths in a pass. And it would just be, but if you get somebody with a laser cutter, that's going to be super simple for them. Super simple.
Yeah, we're working through it, man. But I'll keep you updated if something changes.
That's okay. I mean, like you, I put a little bit of effort into it. And I'm, professional curiosity. Yeah. What happened? That's all. All right, man.
Yeah, no. Yeah. All right. Well, you're welcome. Thanks for the call.
And thank you for the information, sir. Bye-bye.
Yeah, no problem. Bye.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.